This is the notes for 2.4 cubed roots. So yesterday we looked at when something was squared. This was the second power. Today the cubed root is when it's the third power. Okay, so for example, 2 is the cubed root of 8, meaning if I did 2 times 2 times 2, 2 times 2 times 2, I would have a three-dimensional box that had 8 cubes inside for the volume. The symbol with the little 3 inside the square root is when I'm working backwards. Okay, so in this example, we said 2 to the third power equals 8. So then if I did the cubed root of 8, that would equal 2. Okay, those are how they go back and forth between each other. Okay, let's start with today just making a list of all of our cubes. So 1 to the third power would be 1 times 1 times 1. 2 to the third power would be 2 times 2 times 2, which is 8. 3 to the third power, 3 times 3 is 9, times 3 again is 27. 4 to the third power, 4 times 4 is 16, times 4 again would be 64. 5 times 5 is 25, times 5 again would be 125. You'll notice today they're getting quicker even faster because I'm doing that same number times itself 3 times. Okay. Once I get to 6, I'm going to go and start using my calculator. So yesterday we used where it had the square. Today there is no button that has a 3, so I have to use my caret. Okay, so to do 6 to the third power, I'm going to hit 6, this button right here, to the third. So 6 times 6 times 6 is 216. 7 times 7 times 7. 7 times 7 is 49. Times 7 again, I do 7 caret, and then my 3, 343. 8 to the third. 8 times 8 is 64, times 8 again, I'm going to use my calculator, 8 caret, so this button right here, to the third, 512. 9 to the third, 9 times 9 times 9 is 81 times 9, so again we're getting big, 729. And then the last one, 10 times 10 is 100, times 10 again gets us to 1,000. Okay, so you'll notice as I times the number by itself 3 times, my list is going to get really big here really fast. Okay, we can also use this list though to do the same thing we did yesterday and estimate the cubed root. So anytime there's a 3 here inside, I'm just looking for a number times itself 3 times instead of yesterday was just squared. Okay. Also make a note to yourself in your calculator, it's this button. That's my caret, that's how I get the third power. If I'd like to do this cubed root, then I have to hit second first. Clear that out. Second, and then I use that button, and it'll do something inside my square root. Okay, so you see how it paired up with an answer? That would take my answer from last time. So before I hit that, if I wanted to do, let's say, the third, I would hit 3 first, and then second, that button right there. That would put the 3 up there in my spot. Okay, so we can test it. So like the cubed root of 512, what times it's what itself 3 times would get us to 512? Should be 8. Okay, so this button is anything other than squares. To the third power, fourth power, fifth power, anything works. And then same thing above that. So we're going to hit the second button first, that blue one, and then that will allow me to get up to the one that looks like this. Okay, so just make sure you type in the number first and then hit our second and type that part in. Okay. All right, so let's go ahead and try a couple more here. If you flip your notes over, we have 3 different ones that have squares and then one that's a cubed root. And we're going to try and put them on a number line. So let's start with our square root of 5. What times itself would make 5? Well, the square root of 4 is 2. The square root of 9 is 3. So my educated guess would be probably something small like 2.2. Okay, but let's double check. So in my calculator, we can go ahead and hit above the squared. There's my square root. So I can do second squared. There's my normal one. And we can approximate my decimals about 2.2. So on my number line, Put it right here, 2.2. And I do need to label this, okay? So when I plot it on my number line, it's a dot on the line. It's not a hovering X or a dot above it. My dot is on the number line, and I'm gonna label the square root of 5 is approximately, that little squiggly line, 2.2. Okay. The square root of 1, 1 times 1 would make 1. So that one's nice and easy. We're at a whole number 1. The square root of 1 does equal, so I don't have to use that squiggly line. 1 times 1 made 1. Okay. Where it's going to be a little trickier today, if there's a negative out in front, that means I'm going to do the square root of 2. So we're looking between 1 and then 2 times 2 is 4. So I'm going to guess it's probably 1.3, 1.4. I'm going to put it in my calculator. We go second, and then my squared. So if my decimal is supposed to be 1.41, but there's this negative sign out in front of it, when I go to plot it, I need to be on my negative side of my number line. Okay, so I'm counting back from 0, from negative 1 to negative 2. So negative 1, negative 1.1, 1.2, 1.3, 1.4, be about right there. Okay, so as I'm counting backwards by tenths, this was slightly bigger than negative 1, and it was smaller than negative 2 squared. So we put 1.4, so negative square root of 2 is approximately negative 1.4. Okay, feel free, you can put these in your calculator today. You don't have to estimate like yesterday. I think it'd be a good place to start, but then please double check it in your calculator before you try and put it on your number line. Okay, and then our last one says the cubed root of 8. So what times itself 3 times would make 8? And that's 2. 2 times 2 times 2 is 8. The cubed root, so I had the little 3 in there, is 2. Draw an arrow to that one. Okay, so there's going to be a lot of them on your number line today. Feel free, you can give them a letter, so like A, B, C, or D, and you can label this as A, B, C, or D. That's how it appears like on your test. Okay, but just make sure there's some kind of label. Your teachers can't check it when you turn it in if all we see is 6 different dots, because if one of them's off, we're not sure which one you messed up. Okay, so please label which one you think when you put it down, so that way you can make sure you get to all of them. And then if you mess up on one, it's an easy fix when you come up here to check it. Okay, one last thing I'd like to add, just at the top up here. There is a difference between the cubed root of 216 and the cubed root of negative 216. Okay, so if I was going to put this in my calculator, I'm going to go 3 first and then second with the special one, so above my square. So this is the cubed root of 216. So what times itself 3 times? Well, 6 times 6 times 6. Okay. But what's different about this today is that it cannot have that plus or minus symbol on the side. Okay, there's no such thing as a plus or minus in the cubed root. If I did negative 6 times negative 6, I would have negative 36 times another negative 6. That would make a negative answer. Okay, so there's no such thing as both. It's either one or the other. So in this case, negative 6 times negative 6 times negative 6, that would make a negative inside. If it's a square root, there's no possibility of that negative being inside, because a negative times a negative will always give you that positive answer. Okay, so it only works if there's an odd exponent up here. So if it's a 3, a 5, a 7, then it is possible to get a negative inside. Okay, so let's show it again. So 3 second, and then my squared. And then I can use my negative button down here of 216, and it'll tell me my answer is a negative 6. Okay, so a negative times a negative times a negative 3 times, because it's odd, that's the only thing that can make a negative inside my square root.